All right, guys, this is your second lesson this week. We're continuing in line segments and distance. Today, we're really going to focus on the distance formulas. Um, so, we're going to be doing some algebra with our geometry. This is when geometry gets fun. Um, so, the first thing we're going to look at is the distance formula. So, if we have a number line, um, we can find the distance between 2 points using this. It is the distance is the absolute value of x2 minus x1 or x1 minus x2. The order does not matter here, but that's how we're going to find our distance. Um, and you're going to see more when we do an example real quick of what we mean by that. So, use the number line. Find the distance between B and E. So B is -6 and E is 2. So B is -6 and E was 2. All right. So you have x2 minus x1. So they chose E to be E to be x2. So what you're just saying is we're labeling this x2 and we're going to label this guy x1. It doesn't matter which one you do. So we put 2 minus -6 in absolute value. And so you get 2. Well, when you subtract a negative, it becomes plus. So it's 2 plus 6, which is 8. And the absolute value of 8 is 8. And so we could have done it that way. We could have also just counted from -6 to 2. 1, 2, 3, 4, 5, 6, 7, 8. That's another way to do it. Now they want us to determine if CA is congruent to ED. And remember, congruency means are they equal? So we're going to find the distance between CA. So C was -4 and A was -7. So you got -7 minus -4. Remember that becomes plus. So -7 plus 4, which is -3, absolute value. So CA equals 3. And then we're going to find ED. So ED we have -2 and 2. So we're going to have -2 minus 2, which is -4. And the absolute value of -4 is 4. Does 3 equal 4? No, 3 does not equal 4, so they are not congruent. Not congruent. So you're just plugging it in. You're just subtracting them and then taking the absolute value when it's on a number line. It's going to be a little bit different when it's on a Cartesian plane and we got x and y's, but you'll see that in a second. So what we have for when it's on a graph, you have an xy coordinate for both points. So P is x1, y1, Q is x2, y2. And you're going to follow this formula. The distance, in this case PQ, but we say the distance, and then the distance is whatever the variable is going to be. So I froze, so I'm just not going to keep that up. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And the order does not matter, meaning it doesn't matter if I label P x1, y1 or x2, y2, as long as I label Q the opposite. So you'll see that with the example that's about to come. So find the distance between each pair of points. So I'm going to label C as my x1, y1, and I'm going to label D as my x2, y2. Now, it did not matter if I labeled it x2, y2, and then D was x1, y1. What matters is I keep them the same. So my distance here is going to be CD, because that's what I'm trying to find. So CD equals, I'm going to do this in black, and then you'll see in a second. So let's change the color. CD equals the square root of x2 hold on, I'm going to do minus plus. I'm going to fill these in. So x2 minus x1 plus squared. Don't forget our squared. Alright. And then we're going to have y2 minus y1. And the reason I did that is so that you can see the colors. So it's the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. So I'm going to plug in my values here. So I got CD equals the square root of, well, what was x2? x2 is 5 minus x1. What is x1? x1 is negative 4. So negative 4. And remember, we're squaring that. Plus y2. y2 is negative 1. Minus y1. y1 is negative 6. Quantity squared. So if you look at this, I'm going to do this. When we subtract a negative, we're going to change that to a plus, and we're doing that in both situations. So CD equals the square root. 5 plus 4 is 9. So 9 squared plus negative 1 plus 6 is the same as saying 6 minus 1, which is 5 squared, which equals the square root of 9 squared is 81 plus 5 squared is 20. 5 squared is 25. And then I'm going to add them up. And when I add them up, 81 plus 25 is going to be 106. So I have the square root of 106. And I can leave it like that, or I can take the square root of 106 and we're going to say it approximately equals, I squiggle my equal signs, and it approximately equals 10.3 units because we don't have a measure. So that's what CD is. So now we got MN. We're going to do it yet again. And I'm just going to do it all in one color, and you guys can figure it out. But I'm going to label M as X1, Y1, and I'm going to label my N as X2, Y2. And I'm going to say MN equals the square root of X2 minus X1 squared plus Y2 minus Y1 squared. So I'm just going to plug it in. The square root X2, what did we say X2 was? Negative 3. Minus X1. X1 was 2. Quantity squared. Plus Y2 was negative 2. Minus Y1 is 4. Quantity squared. And I'm just going to keep on simplifying. So negative 3 minus 2 is negative 5. squared plus negative 2 minus 4 is negative 6 squared, which equals, well, negative 5 squared. Remember, a negative times a negative is a positive, so it is positive 25 plus positive 36, which equals the square root of, that should be a 6. 25 plus 36 is 61. So it's the square root of 61, which approximately equals 7.8 units. And so that's what you guys are doing today. You guys got another Jamboard. Thanks, guys. Have a good one.